Hello everyone. Welcome to another episode of Electric Power Syrup channel. Today's episode or video is continuation from the previous video where we have created a 3-bus case from scratch. If you haven't watched that video on how to create a power system network in PSSE from beginning, please do check out that video. In today's video, we'll begin from where we left at the end, where we performed the power flow. I want to show few additional features on how to generate some power flow reports or results, and then also a couple of visualization features that one can do on single line diagram. Let's get started. I'm going to launch my PSSE. Then go ahead and open the case I saved yesterday. You can check out the description of that video to find these files. The description contains a link where I have uploaded this. So go ahead. You can load your raw file. Then I'll go ahead open my line diagram. As you can see, it loads in a unsolved because it's a raw data. So I'll go ahead use this shortcut on the toolbar to perform the power flow. I leave everything default, click solve, then close. You can see the power flow converged in 3 iterations. What I'll do is switch to network data and click save as, and I will save this as case data, which is the .sav file, also known as saved case file. It's a binary format of the power flow working case. It saves your solved power flow result, the voltage magnitudes and angles. And it's mainly helpful because it's a compressed form of data storage to save your disk space. And so it minimizes the time required to store and retrieve the data. And the next time you load a case, you can directly load this SAV file instead of the .raw file, and you don't need to perform this power flow again and again every time you load your raw file. That saves a lot of time. I'll go ahead and save this SAV file. Go switch back to single line diagram. I'll show you a few features which you can do for any system or network. The one feature I already showed in the previous video. So let's quick recap. You can hit this yellow kind of ribbon button. I just zoom in here. You can see animate flows. And if I click, it will show you the flow of the power in the network. Very useful when you have complex big networks to understand how the power is flowing from region to another. So I'll it off so that I'll show you other features. The first and foremost is how to generate some of the power flow reports. So you go to power flow menu, reports. There are a bunch of options. The area or zone based reports are helpful when you have big systems, multiple areas and zones defined. It's sometimes helpful to get area wise. But since this is a sample 3-bus system, it's single area and zone, I'll just show you how to do bus based reports, and then we will talk little about limit checking reports. So let's first check bus based report. I'll go ahead and click, and I'll just select these options so get we get the maximum details in the output. And you can limit the result or report for certain buses. So you can select like which buses you want specifically here. Let's say if you want just the bus one. But for this video, I'll just select all buses so that we can see complete result. Click hit go. And you can see in the output bar area, it generated this new tab and it has this power flow report. I'll close this. Let's expand this area. You can see the complete result here. There we go. So you can see here it generate the bus based report. For each bus, it specifies how many transmission lines it has, from which bus to another. Like from bus 1 you have a transmission line 1 to 2, and then bus 1 you have another line to bus 3. So here you have just initially the bus information, and then you also have the transmission line flow going out from that bus 1 to towards the other buses. It also generate this network results new tab. It's the same info but in Excel format. You can select on this topmost left square so that it selects this entire uh, Excel table or network result table. And then you can do right click. It will give you option here. So just go into this corner cell, select right click, and it says, as you can see, you can export this selected data to an Excel or CSV file and then store your results or do some other analysis. This is one of the reports which you can basically save your power flow results, your voltages, angles, magnitudes, and so on, or how much your slack bus or generator is producing active power and all the reactive powers of the generator. You can see all that information. So that's one. I'll just close this. You can do similarly for this result as well. You can right click in this area and you can see click select all, and then you can copy and paste it any text editor file to save this result in this form. The next I want to show is the same. Go back to power flow reports, limit checking report. Now there are a lot of cases where you are trying to check the problems in your network, like if there is any transmission line overloading. What I mean by overloading is the transmission line have a capacity limit of how much power it can transmit, and if your system is actually transmitting more than that, it's called overloading, and you can visualize those things here. But if it's a small system, but if it's a big system, you may want a complete report of where or which transmission lines there are overload. You can also check for voltage limit violations. That is, each bus has voltage minimum or maximum limits. And if the power flow solution results in voltages that are lower or higher than the limits, then you would like to see those. So to do that, you can go and click on limit checking reports, and you can see there are a lot of options. The import or the one I wanted to talk about is this branches tab. It may launch in generator bus or some other tab when you click on this, but just switch to this branches tab and we'll see which of the transmission line are overloaded. I'll go ahead and click go. And you can see it again generates the output report here in the output bar area, and it says none. And this is because if you notice, when we created this 3-bus system, We did not define any transmission line rating. They are all set to 0. So that's why you don't see any report or information. Let's go ahead and define some rating values, fictional. So I'll go to line 1 and 2, or line 1 to 3, and you can see this rating, rate 1. I'll just make it like to 50. Click OK. And remember, as I was mentioning, you can change the rating here, or you can go to network data, branch. Let's expand this. And if I scroll a little right, you can see this rate IMVA. I changed 250 there and it immediately reflected here. So I can change the data directly from here as well. So let's do that as well. Select this cell, just type in from your keyboard and then press down arrow key, or from your mouse select another row. And if you go to progress bar, it will show all the changes you have been doing. So the action, so you can see it says original value was 0 and now the new value is 250. And I'll go ahead and change the final third, the remaining transmission line as well. So I have changed all the 3 lines rating as 250 MVA. So now we'll go back to our single line diagram, right? Go back to power flow, reports, limit checking reports. Now I click go again. And now you can see there is a line which is overloaded. So that's how this report can be useful. Another feature in visualization for the same um, overloading of transmission lines, you can click on this rectangle here, blue, uh, beside the animate flow option. It says current loading. If I select that, you can see it shows you how much the transmission line is loaded in comparison to its capacity or limit. You can say this is almost uh, near to its capacity, 96%. And then this line is 55%. And then this is the transmission line which is overloaded, 122%. Now you may be wondering that here it says uh, like the percentage overload 116% and here it's 122%. That's because there are two types of overloading percentage to compare. It either based on current or based on actual MVA itself. So if I go back in power flow, or sorry, diagram, click properties, and you can see here the branch annotation. Here you can select that to show a different type of flows. Right now it's just showing us active power and reactive power flow. These are different notations and you can decide what kind of information you want to see on your single line diagram. But I want to catch your attention over this loading basis for percentage rating. So right now it's set to or default value current expressed as MVA. But I will change it to MVA since the rating we provided are like the direct MVA rating, but it changes or depends from case to case or application to application, where in some practical use cases, the information you have are the actual current limits. So I'll change this to MVA, click OK, and you can see this percentage changed from 120 to 117%. Now you can see it matches the output report over here. So recap, we studied two different types of reports: bus based report capture the power flow results like voltage magnitude, angles, flows, generator outputs, etc. And then the limit checking reports to see if you're in your system there are any violations anywhere. One final thing I wanted to talk or show today is sometimes it's very appealing to see how the voltage profile looks like visually, uh, if you have, especially if you have a big system. And you can do that through contour. So you need to be in a single line diagram selection. Go to diagram. You can see this option contouring. Click on enable contouring. Leave all the default options. You can modify or customize if you need, if your min or max is different, but I will leave it as default and then click OK. And you can see it generates this nice visual voltage contour. And what this basically means is green is where voltages are close to 1, yellow is above or greater than 1. In most cases, when it's red, it's closer to its upper limit or beyond. So this is sometimes useful to quickly locate the areas or zone where you may have voltage issue. And that's where this could be very powerful visually to identify those. That's all I wanted to cover in today's video. In the next video, I will show how one can perform the DC power flow. This was all about AC power flow in this or the previous videos, but in the next video, I'll cover how you can do DC power flow in PSSE. Till then, take care and please don't forget to like, share, and subscribe this channel to stay tuned with up to date news, videos, and information. And if you have any request for any particular topic you want me to cover, please do leave a comment in the YouTube on this video, and I'll try to accommodate that in the future video. Thank you.